Hello there, welcome to the October 2020 paper. Here we're on question 2. So part A is explain why the integral from 1 up to infinity of 1 over x 2x plus 5 dx is an improper integral. Well, the reason is because there's an infinity on the upper limit. And that's all you have to write, it's just because there's an infinity symbol on the upper limit. Moving on to part B now. Part B is prove that this integral is equal to a ln b. The first thing we need to do here in this question is to split the integral into partial fractions. So that's the bit I'm going to concentrate on first. So 1 over x bracket 2x plus 5 equals a over x plus b over 2x plus 5. Whoops. 2x plus 5. Let's multiply now by x, 2x plus 5. So I'll get 1 equals a lots of 2x plus 5 plus bx. Let's expand the brackets on the right hand side now. It's going to be x lots of 2a plus b plus 5a. So therefore it must be the case that a is equal to 1/5. And therefore b is equal to minus 2/5. So therefore the integral is going to be the integral of 1 over 5x plus, minus 2 over 5 2x plus 5 dx. Okay, so now that we've split it up into partial fractions, what we can say then is that this integral here, now the way we deal with the infinity symbol on the top is we say the limit as t tends towards infinity of the integral from t to 1 of, and then it was 1/5, wasn't it? We could factorise out the fifth to the front here. It's going to be 1 over x minus 2 over 2x plus 5 dx. Okay, so we could even factorise this fifth out right to the front. So it's going to be the fifth times the limit as t tends towards infinity of the integral from t. Actually, no, we can integrate now, can't we? So it's going to be ln of x on the first integral, and the second one is a perfect ln integral as well, ln 2x plus 5. From the limit t down to 1. The next thing we'll do is we'll combine this into a combined logarithm. So the limit as t tends towards infinity of ln bracket x over 2x plus 5 from t down to 1. Now we need to consider what will happen if we put t in and set t. In fact, let's put t in first. Limit as t tends towards infinity of, so now it's going to be ln t over 2t plus 5. And then put 1 in, so subtract ln of 1 over 7. Now we consider the limit as t tends towards infinity. So as t tends towards infinity, well, what's going to happen as t gets very, very big? If we think about t as like a million, it's going to be 1,000,000 over 2,000,005. Well, that's going to almost be a half. So what I'm going to say here is that t over 2t plus 5 will tend towards a half. So therefore, this integral is equal to 1/5 ln of fifth brackets ln of a half minus ln of 7th. Let's now just get rid of those fractions by factorising the power of minus 1 to the front. So it's now going to be minus ln 2 plus ln 7. So effectively we thought of both these fractions as 2 to the power of minus 1 and 7 to the power of minus 1 and move those powers of minus 1 to the front. Now let's combine these two logarithms, so it's going to be ln of 7 over 2 times 1/5. And there we are, that's the answer for this question here. So this is how we deal with limits when there is an infinity symbol on the boundary. We deal with it as a limit we put t on the top boundary, and we then think about t tending towards infinity. Make sure you clearly state what you think will happen to the function with regards to t as t tends towards infinity, and then use it in your later workings out. So there we are, that's the answer for question 2 here, worth 7 marks in total. A bit of partial fractions, bit of integration, bit of improper integrals as well. Lovely, thanks very much for watching, and move on to question 3.